Here we have the solutions for the IB Physics Unit 5 Electricity Test for 2010. And the first question, a proton of mass m and charge E is accelerated from rest through a potential difference of v. The final speed of the proton is. Now, this is a direct application of this formula over here. Just to go through this again, this VE comes from the idea that your potential difference is equal to your work over your charge. Therefore, work is equal to the V times the charge. When you're dealing with an electron or a proton, this charge is, you can replace it by an E. So EV or VE is equal to the work. And that work, it changes the electrical energy into kinetic energy, and that's why you get the half mv squared. So to get your velocity, obviously this is your velocity over here, so it's going to be multiplying by 2 and you get your VE, and then you're going to divide by your mass. So divide by mass, and that will equal v squared, and then obviously you take your square root to get rid of the square. So answer A would be correct. Question 2. The battery transfers EB when charge Q passes completely around the circuit, and the resistor energy transfers energy of E to the small e, to E to the R. The EMF of the battery is equal to, it's going to be B, because the EMF is the total energy that a cell can supply, and that would be the EB, because notice it says is the transfers energy EB when the charge Q passes completely around the circuit, So what's happening here, as it's going around, it's going to, as it goes through the resistor here, there's going to be energy used, and as it comes through the cell, because can be eternal resistance, there can also be energy lost here. So this will be the two places where energy will be transferred. Okay, going on to question 3. We have here, in a circuit shown below, the cells have negligible internal resistance. Which of the following is correct? Now, in looking at this, we notice that we have got an R and a 2R. So the current, this is I1 over here. This current is actually going to split there and there. And the proportion that will split will be in the proportion of the resistances. So you've got here 2 R and is to R, so it's 2 is to 1. So this is where there's higher resistance. Now your current will go, your most current will actually go towards where you have the least resistance. So you'll have 2 parts of your current will go there, 1 part will go there. And so the answer for this one, when we look at it, we've got a number of different ones. We've got I1, and we can see that I2, because this is where you've got this would be your I2, where you have got your resistance there, and this will be your I3. So we can see here that you're going to get double the amount of double the current of your I1. So it is actually going to be C would be your correct answer there. Can you see that here we have that I2 is equal to 2I3, so you've got 2 times the current here as you have there. You've got this is equal to twice I3, which is correct. Looking at this question over here, question 4. The graph below shows the variation with potential difference V of the current I in an electrical component. Which of the following is a correct statement about the resistance of the component? Now, resistance is always the ratio of your V as to your I. So we have that. Now, in looking through these, the potential difference, for potential difference greater than V0, the resistance is constant. Now, that actually wouldn't be correct. Let's just put in a few numbers here, and we can say this over here is 2. Obviously, that's 0. Now, let's go across, and we can do some equal values. So that would be 4 and 6. Just say we put those values in, and it goes up here, and let's say that has got a current of 1, and that would be like a current of 2. So in this case over here, we're going to get my R is equal to V over I, so we'll get 4 over 1, so your resistance is 4 ohms at this point here, and for this point over here, your resistance is going to be 6 divided by 2, which is equal to 3 ohms. So the resistance is actually changing. So which one would be the correct one? Let's have a look at B. For potential difference greater than V0, the resistance decreases with increasing potential difference. This definitely seems to be correct. Let's just try another one here. So if this was 8, we went up like that, that would be 3. It would be 8 divided by 3, which is 2.67 or so. So you can see it's going 4, 3, 2. So this is definitely correct. B is correct. So it's important to realize that the resistance is not the slope, but it's the ratio of your V as to I at any specific point in any specific time. So going on to our next question, question 5. We have the resistors in each of the circuits shown below. Each have the same resistance. Now, I'm going to put in a value for that. I usually like to do that. So let's just say each of these have got 1 ohm. 1 ohm, 1 ohm, and 1 ohm. And we can work out the resistance for each one of these. Now, this one over here will have, because you've got 1 ohm, 1 ohm, 1 ohm, that's going to be 1 over R parallel will equal 1 over 1 plus 1 over 1 plus 1 over 1. And so when we put this together, when we add them together, we get 3. So R parallel is equal to 1 over 3 when we invert that. So the resistance here is actually going to be 1 plus a third. So for circuit P, we've got our resistance is 1 1/3 ohms. For this one, we've got 1 ohm and 1 ohm, 1 ohm and 1 ohm. So here we're going to have 2 ohms and 2 ohms. And when they're in parallel, and we find 1 over T plus 1 over 2 plus 1 over 2, we get 1. So the resistance for Q actually turns out to be 1 ohm. And the resistance for circuit S, we're going to have 1 ohm, 1 ohm, so that's already 2 ohms. And then these are in parallel, so it actually works out to be half an ohm here. So for this one, it's going to be 2.5 ohms. So which of the following gives the circuit in order of increasing total resistance? So obviously Q is first, P is second, and S is third. So B would be the correct one there. Important to make sure that you check it very carefully and read. You make sure you get the order correct. Putting in, using a value like this, using 1 ohm or 2 ohms, and using a value also helps. In question B, in which one of the circuits is it possible to vary the current in the lamp by adjusting the variable resistor? In looking at this, I didn't see one right answer here. All of these, I think, would cause some variation in the resistance. So I'd like to scrap that question over there, question 6. Question 7. In the circuit below, the battery has negligible internal resistance. Lamps L, M, and N have different resistance, are connected as shown. Which of the following is always true? Lamp L and N have the same current through them. L and N. Well, they wouldn't, because they've got different resistances. You will get, depending on the one that's got the least resistance, will have the most current going through. So that definitely is not correct. Lamps L and M have the same current through them. L and M. Well, that wouldn't be true, because this would have all the current. This would have the current of both L. The current of IM would equal the current of L plus the current of N. So unless this was a very high resistance, like infinite resistance, then that would be true, but generally that wouldn't be true. Lamps L and N have the same potential difference across them. That is true. That is true. They will have the same potential difference across there. So C is correct. And question 8. In the circuit below, the battery has an EMF of 6 volts and negligible internal resistance. The 3 resistors each have 10 ohms. A high resistance voltmeter is connected as shown. The reading on the voltmeter would be, well, in looking at this, these two over here, they would have a combined resistance. 1 over R for the parallel would equal 1 over 10 plus 1 over 10, which equal 2 over 10. So RP, which is your inverse, would equal 10 over 2, which would equal 5 ohms. So the total resistance would equal the 5 ohms, which is the equivalent, 5 ohms, plus the 10 would equal 5 plus 10 would equal 15 ohms. And therefore, you're going to have a current. The current would equal I is equal to V over R, would equal 6 over 15, which is equal to 0.4 amps. If that's correct. Okay, so we've got that. Now the potential difference therefore across here, the V, if you've got 0.4 amps, that would be 0.4 times 10 would equal 4 volts. So the balance must be across here. This must be 2 volts. If you can have 2 volts plus 4 volts, giving you 6 volts. So A would be your correct answer there. And then question 9. A conductor of constant resistance dissipates 6 watts of power when the potential difference across it is 12 volts. The power that will be dissipated in this conductor when the potential difference across it is 24 volts would be. Alright, so remember we have that it says here, this is an important statement, a conductor of constant resistance. So the resistance remains the same. So let's work out what that resistance is using our formula here. Power is equal to V squared over R. So R is equal to V squared, which is 12 squared divided by our power, which is 6. That's 144 divided by 6, which is 24 ohms. So when we increase the voltage to 24, we're actually also going to increase our current, because I is equal to V over R from this formula over here. So we're going to get 24 divided by 24, because remember the constant resistance. So that's 1 amp. So when you have got 24 volts, then using this formula over here, power is equal to VI, we're going to get 24 volts times the 1 amp, which will be 24 watts. So C would be the correct answer.